Dear students, today in plus 2 semiconductor lesson, one important topic. Actually, if you observe in the electronics, otherwise generally in the physics, you have to introduce something, or you have to find something innovative. It should be useful to the society. So you should understand the basic concept of the that every theory part. So from that theory part, you have to think something. Then you have to introduce newly. These questions also, that is the best example for that. Say for example, let's take PN junction. In that PN junction, you know the forward bias and the reverse bias. So in the forward bias, we can get more current comparing with the reverse bias, because in the forward bias, the responsibility charge carriers are majority. I mean the majority charge carrier only that responsible. But in that reverse bias, minority charge carriers, comparing with the majority, minority is very few only. So we can get microamps level current only. Okay. But in the reverse bias, we get very small amount of current. Then why we didn't get more amount? Just if you think. Reverse bias, always we can get low current. Okay. So, but we want to, we need more current in reverse bias, what we'll do. Okay. So that thinking only to introduce new idea, to introduce new application. Okay. So that only we are going to discuss in the class. Okay. So our target in reverse bias should increase the current value. How? So already we know there is a PN junction, how it is response in forward bias and reverse bias and everything. So we have to do something. So externally we give something like a light source. Light source is nothing but photons. We apply the photons to the diode. That is photodiode. So now we are going to discuss photodiode. Actually photodiode. Okay. It is a combined together. That's a photodiode. Okay. So photo is nothing but it's a light energy. So by using the light energy, we can operate in the diode. So here generally simply we can say that light energy converted into that electrical energy. Okay. Then how? For example, the same as it is like a PN junction diode, but we have to apply that light energy. Okay. So where? In the junction. Okay. So let's see that diagram. Listen and draw here. Okay. Please listen, students. Okay. So I can split in the, it is the junction. Okay, for our convenient, I draw a little bit large. Okay. Yes. So we know that it is it's imaging. So this node don't. Okay. Now listen. So it is it's a P region. This is that it's an N region. So now here we introduce one transparent window. It's a transparent window. It's one of the top part only, top position only. Okay, not in the side way and bottom. Okay, here as usual only, it's like a junction. Okay, so here one transparent window. Okay, so it is this black color is represent transparent window. Okay, so now we are going to apply the light energy, that is a photon. Externally we apply. Okay, if it is sunlight means naturally will come. Okay, anyhow we have to apply the light energy on the transparent window, on the diode. Okay, so you know that this is like a normal PN junction initially. So normal PN junction diode, you know that it is normal PN junction diode. So P region and N region. Now here the light is supplied on the diode, so it is a symbol, light is falling on the diode. Actually this is the symbol for photodiode. It's the actual symbol. Okay, right. Then how we can operate this? Okay, so you know very well this photodiode, it will be connecting with what is it, reverse bias condition. Okay, so the reverse bias conditions, you know, that's here positive, I mean P region connected with negative, then N region connected with the positive. Okay, now this is in a reverse bias. Okay, so like that now we can connecting here negative, positive. So please listen students, it's minus and plus. Okay, now the same thing only. So now we can apply the, what is it, light energy. Okay, so on the transparent window. So the very first point, it is operated by only reverse bias. Okay, then second one, here you know that input is, that is a light energy. Okay, then one more thing, you know here what is it, band gap. Okay, so that energy band gap, I mean in the in the diode, actually in this diode energy gap, you know, there is energy gap is Eg. We have to apply some energy. That energy is, you know, E. That is E is equal to H mu. Okay, E is equal to H mu. So this apply energy should be greater than that energy gap. Okay, then we can get the response. Okay, then next step, while we applying that heat energy, here that the electrons and the holes pair will be increasing. Okay, so while we applying the light energy on the diode, then electrons and the holes pair will be increasing. Electrons and the holes concentrations will be increasing. But here, whenever the electrons and the holes concentration is increasing, where in the junction or near the junction, okay, so it try to recombine one another. But you know very well, this is the reverse bias condition. So in the reverse bias, before going to recombine, it will be separated by this potential. Okay, it will be separated by this potential. So due to the separation by this battery, so these holes are moves to the P region. So the holes are moves to the P region due to reverse bias. Okay, at the same time, the electrons are moves to the N region. So these electrons are moves to the N region. Because it is a negative terminal, it is attack the holes. So it moves to the P region. Then here positive, it will attract the electrons, it move to the N region. Okay. So normally in the PN junction diode, this is happen only for the minority charge carrier. But here externally we apply the light energy from the light energy electrons holes are generated. So that electrons and the holes, it will be attracted by the what? By the battery. So comparing with the normal diode, here we can get that more current. Okay, then what is the use? Okay, see that. So before going to that, then we can drop that current value, okay, by using that one load resistance. Okay, so then see that. Now I am going to explain the uses. Okay, so we did some alteration in that normal PN junction diode in the reverse bias by using the transparent window. Then what is the use? Yes, that is usage is, see that when the intensity of light is increasing, okay, that photo current also increasing. So what is this meaning? We can detect the light energy, whether the light is falling or not, whether light is present or not. Okay, so which is used to find that detection of photons. So this another name we called as, that is a photo detector. Photo detector. Okay, so it is mainly using in like optical communication. Okay, so I will explain later this application. See that. So here that intensity of incident light. Okay, so and the intensity of incident light or okay, it's not like that. So the photo current, that is exactly correct. Photo current is directly proportional to intensity of incident light. Okay, when the intensity of incident light is increasing, the photo current is increasing. Okay, right. So we have to draw that VI graph here for this VI graph. So we know very well, please listen students, it is in forward bias. Now it is in a reverse bias. So now we know here the reverse bias only we are discussing. Okay, so here in that voltage, here you know the current in the reverse bias, voltage in the reverse bias. Okay, so here suppose now we are increasing the intensity of light. So generally intensity increasing, the photo current is increasing, that's okay, but that's also some limit is there. Okay, so even increasing that more what is that input intensity, you are increasing more and more level. After reaching certain stage, that output current should be, that photo current should be the constant. That is, it's reached saturated level. So this graph for low intensity we can get like this. This is named as I1. Again the intensity little I increase. Okay, say for example, okay, for understanding purpose, it is one intensity, I can get I1 current. Again I increasing intensity level, so it is like I2. Again I increasing intensity, it's like I3. Okay, so if you observe that here, I1, I2, I3 is not a current, it is intensity. Okay, so here I3 is greater than I2, I2 is greater than I1. So this is the nature of the graph. Okay, okay students, so finally I want to discuss this application. Okay, see that these applications I'll write here. Okay. So this application maximum, you know that it is in reverse bias condition. So this is also like used as on off switch, but it is very quick process, nearly in 10 power minus 9 second, in a nanosecond. Okay, so it should be very fast. Okay, and then the next one, it is used as a light detector. Okay, so I say for example in that science exhibition also will show that, okay, clamping light and something. Okay, so just to remember, they are using the photo detector. Okay, so if you hide your what is that? Suppose that light is falling on the detector. Okay, suppose if you hide the light, then something will be operated. Okay, then if you remove your hand, the light will be falling on the detector, then it will be conducting. Okay, so if you hide, light is off condition. If you remove your hand, light is on condition. So like that, what is that? Clamping light. So some applications is there. So just to remember whenever you observe that kind of project. Okay. Right, that is a light signal. Then it is a major use in optical fiber communication. It's very useful. So optical fiber communications. Okay. Then the next one, it is mostly used in that instrumentation. Instrumentation in engineering field, like it is used in it's a controlling device. Controlling devices. Okay, in the controlling device we are using. Okay, it's one of the parts. And then the mostly in that some automatic devices. Okay, some automatic devices and like communications we are using. Okay students, I hope you understood. Okay, from that photodiode, I mean from the normal PN junction diode, how we are developed the next level. Okay, so the next level means that is application. Okay, thank you.